Hello friends, today I'm going to talk about collection framework. What is collection framework? Collection framework can get so lengthy and it could go for hours when we try to describe this. There's so many things to cover, so I'm trying to cover this up with as briefly as I can, and possibly this could go for another 20 minutes or so or more. So basically what the collection is the representation of similar objects, right? So similar objects will are being addressed as a part of the collections so that you can get along to play with all different types of data in the objects. Make sense? So for say you have a page that has like hundreds of links that you don't know how many they are. You don't want to end up counting them, right? Sometimes you have to deal with this type of data that you don't know, right? Invisible data. You don't know the sizes of them and how you want to deal with them, right? So for say you have an array. If you want to define an array will have to be some fixed data, like the size of the array that you have to first initialize. You have to define size of the array if you want to create an array, right? So and then you have to end up defining each individual indexes. That at some extent may be helpful, but you don't want to end up doing that as longer. That is not really helpful. In as the data may be dynamic and it continues to grow and you don't know the exact sizes of those data could be, and these are all similar, you don't want to create hundreds of objects and instances just to represent similar types of the data. This is when after this is when the collections became popular, and that's what it get addressed. Okay, so collection framework started with Java, the first release 1.0, and then they continue to add some stuff in 1.2, and then also have something that came in at 1.5. So let's go with the collections. First thing is the collection framework. Don't get confused with that. So overall collection framework is a different thing than the collection interface and the collection class, right? So collections class and the interface, you might get questioned on interviews. If you go, they might ask you what is the difference with collection and the collection interfaces. Don't get confused. Collections is a class that contains all static method that you can use them, right? Whereas collection is the interface that is being implemented with all different interfaces, and which is part of the collections framework. So which is what we're going to discuss further. And we have two sets. This is basically the brief descriptions and the diagram I prepared in order to cover this class, and hope this will be much helpful for you to get like kind of brief idea about what the collection could be. And this is just designed so that you can just come into this video and look for another 25-50 minutes and then refresh, kind of just quick memorize, right? So I have two sets. So one set is part 1, part 2, part 3. This is part of the collections interfaces and their implementations, and we have another which is also the part of collections framework, but this has a map interface. This has nothing to do with the collections interface, and we're going to talk about what implementation map interfaces would have. Okay, so what are the implementations of collections? So collection interface is extended by 3 different interfaces. Okay, and one more thing I wanted to tell you. So when interface try to inherit the interface, you have to use the keyword extends. So when I say extend, don't get confused. Extend only applies class to class, interface to interface. Okay, similar thing, you use extends. Class to interface, you use implements, right? So don't get confused with that. So collection interface, list interface, set interface, navigable, sorted, and I have, I put this I that represents the interface, and Q interface. These whole things are interfaces. So first let's talk about list interface. So collection interface is being extended by list interface, right? So list interface is implemented. There are implementation of the list which are array list, linked list, and a vector. A vector is considered to be, legacy. It's a synchronized third ceph. It does everything that array list does, except this is the third ceph. Array list and linked list are a little bit different, and the way which you may use depends on your type of operations. If you are trying to represent the similar entities, which is like a heavily used for searching and trying to find objects within the list, then you might want to go with the array list. And this is non-synchronized, multiple threads can access simultaneously. And linked list is basically considered to be faster than the array list. Linked list is good for insertion and deletion operations, so that's one thing. And then linked list is basically you want to delete something, it deletes from the first header, and then if you want to insert something, that goes all the way to the last of the list, right? So and then so that's the main thing. It also let's go with one quick thing here. So it also implements the queue interface. That's part of the linked list, and what it does is it any elements you add, it goes to the end, and then you when you try to remove them, it's going to remove the first one. So first in, first out, that's what the list does. And list is considered to be faster than the array list, and depending on what you try to do, insertion, deletion, linked list is faster, and rest array list. And as far as you want to know what's heavily used, array list is heavily used than the linked list that everybody plays along with. Array list is more similar to the array, and it represents the indexing, where you can play with array list by using those indexes, for looping, and then play with that. And next one we want to talk about is the set interface. Oh, one more thing. And overall, every implementation of list allows the null values, so you can have as many as null value you have, and then you can and in the list, overall list, it maintains the insertion order. That means the way you insert the value, it maintains the same way. Duplicates are allowed. You can put as many duplicates as you want. There are these methods you can use in these implementations, so depends on which class it's using. Overall list contains add. When the add, you pass one object as a parameter. You have remove. You can remove the objects just the way you added. You can add by providing the index number, and then it will add at that index. And you can add and get set all size, and you can retrieve the sizes of the list. So these are basically the list interface. Okay. We have next is a set interface. There's a differences. You might get so many questions into the interviews. What is the difference with the list and set? Mostly set is similar to the list. The only thing different with the set is set only allows you one null value, and it does not allow any duplicates at all. So it does not allow duplicate means you try to add the two duplicates, the second one never gets added. Okay. There are some confusion that people think that it only returns single value, which is also fine, but it is not returning because it is not even adding it. Okay, so you try to add same value into the set, and then you try to read that out. You could never see the added size on the duplicates never adds up in the set interfaces or any of its implementations. And next thing is as opposed to list interface, set interface does not allow the duplicate values. Only one value is, so which means only unique values. only one null value is allowed. And on the set implementation, there's no guarantee of the insertion order. Okay, so these are the key features of the set implementation, set interface. The methods that you could use with the sets are add, clear, clone is empty. Basically that's the boolean, and then you have a size, and these are the methods that you can use with the set. The implementation, the classes that implements the set interfaces are hash set, and the hash set is same as I told, so there's no insertion order, is not maintained, and that's all. We have another called linked hash set that extends the hash set. So both of these are the classes. So when I say extends, it extends this hash set class, which means it contains all of the methods that hash set has, as well as it has some overridden method that maintains, that overrides to have extra feature where you can actually maintain the insertion order. The rest of them is same, but it does not take duplicate and so. But only thing different is the insertion order, the way you enter is being maintained. Okay. So navigable set. So here set interface, sorted set, extends the set interface. These are both interfaces, as well as navigable sets. So these three implementation, when you come to the tree set implements sorted set, as well as sorted set implements the set interface. So which means tree set contains all of these methods that tree set overrides them, right, and then have accesses to. What the tree set do? Tree set does the same thing that set interfaces has defined to. Only the thing different with the tree set is it sorts the values in some sort of ascending order by default. Okay, so tree set only different is it will allow user to use the tree sets features to get values sorted by default in ascending order. Only that thing is different, and beside this entire except linked hash set, nothing implementation is going to guarantee the insertion order is maintained. But only the thing is tree set sorts everything out, linked hash sets maintains the insertion order, then it does not sort obviously. Hash set, no guarantee of insertion order, and then no sorting, right? And the rest of the key feature is no duplicates, no null except one value. Those are maintained with all across the board. Okay, so that's part of the set interface. And we have a queue interface. Queue interface is basically rarely used, I would say. If you go into the day-to-day activities, day-to-day work, this is like, I would say 70% of collections is used in the list. Out of list you might use over 60% as a array list. And then vector is legacy, you don't see them around anymore. You could see set interfaces, obviously it has its own specialities that people will use it for. So these are considered to be heavily lifted, heavily used. Queue, you would hardly see somebody using them. So there are linked list that implements list and queue, whereas these are used for for this pick, pull, add, remove. These are the methods that are the implementation of queue interfaces. So these are used to add and remove features. That's what linked list is taking it from, as well as it also has a pull and pick. Pick looks for the object, and then pull looks for them, right? So these four methods that you can work with queue interfaces. So again, these are not so used, so you don't need too much worry on this. Rather, I would suggest you spend more time on learning this. So we have another thing. So to move on to map interface. Map interface is part of the collection framework also, but not the collection implementations. Okay, So map is basically the key value pairing. So you would have map implementations where you can have keys. These keys are to be primary key, and um, these keys cannot be null except their implementation. So initially I would say the map interface itself, right? So key and value, that's the main fundamental of the map. So how they get implementations, right? So hash table is the one that came from 1.0, and hash table, when hash table came in, hash table implements the map interface, but there's no duplicate key, no null value at all, nothing, no null value, no null key, right? No duplicates, and then no duplicate key, no null key, no null value in a hash table, and it's a thread safe, it's synchronized, only one thread can use it at a time. So that's the hash table, and it's slow. Okay, so hash map probably came around 1.2, which is Java 2. Hash map allows one null key and no duplicate keys. You cannot have more than one key, so it's just like a set as far as a key, and then any number of the null values are allowed, or duplicate values are allowed, unlimited, right? So that's what the hash map does. Key value, one null value but no duplicate keys, sorry, one null key but no duplicate keys, any number of values. Linked hash map, linked hash map extends the hash map. Only the thing is, linked hash map preserves the insertion order, and rest everything is same as a hash map. Key value pair, this entire map interface is about key value pairing. So you provide key, and you store the value with the keys, and then later on you want to retrieve, you retrieve them by get key. Okay, and there are certain methods that you want to know, so this is how you do. So we have a put method, put has one object comma object, so which means the first one is going to be key and second is value. So and then when you want to retrieve this value, you would say get object, and then it is going to give you this value, the second one. Same thing, you can get a list of what all sets of the keys, or you can also get the empty set in the map implementations. So we have other thing that you want to know about is tree map. Tree map. So here tree map. Okay, so just like you have a sorter set, navigable set, and then tree set, same thing, tree map. Map interface has implementation, extends it by sorted map, and sorted map is being extended by navigable map. Okay, and then tree map implements the navigable map. So that's why tree map contains all of the features that this whole thing has, as well as these are being overwritten. And one only thing different that you would notice on tree map is that this is this sorts the keys by ascending order by default. So that's the main thing that tree map has different than the hash map or linked hash map. Then rest is the same. So overall, this is overall the collections framework. And when you want to go with each one of this in details by defining it into the code and mapping, you could easily go for a week or two. This can be very complex as you go, and this is very widely used. So I would suggest you learn this by heart. You basically remember each and every stuff, and this is how you would, I have tried my best to get this summarized as short as possible, so that you can get better understanding of what the collection framework is for and what you do. So, and this is very widely asked questions, and you might see so many reviews with the collections. So you are expected to know this by by like top of your head all the time. Very important. And you want to see some things here. So collection is interface that is extended by list interface, set interface, queue interface. Okay, set interface again gets extended by sorted set. Navigable set also extends the sorted set. Then tree set implements, tree set is the class that implements the navigable set. Linked hash set is the class that extends the hash set class. Okay, hash set class, that's the one implements the set interface. Here array list is the class that implement array list, linked list, and vector. All these three different classes implements list interfaces. Same thing here. If you want to come down to the map, map is the interface. Hash table, hash map, these all implements the map interface, right? Linked hash map extends the map interface, which means it already has a feature that map interface has, as well as it has the methods that it can override hash map. Only thing different is it preserves the insertion order, as you know, that's all. Sorted map also sorted map extends the map interface, and navigable map extends the sorted map. And navigable map is being implemented by tree map. Tree map is more popular because it also sorts your key values by keys sorting by ascending order by default. So tree map, tree, just learn the word tree, tree, tree with a set, tree with a map. This will help you sorting values, right? Linked, preserving insertion order. Linked is famous for that. Preserving insertion order, right? Preserving insertion order, same thing. Preserving insertion order for linked. Linked hash set, linked list, linked hash map. All three links, preserving insertion order, right? Hash. What is the hash? It does not guarantee you insertion order, right? So same thing here. No insertion order is maintained. So basically these are all similar, but just be careful and don't get confused with one than the other. And if you want to, please continue to watch my video. I'm going to upload other videos to describe each one of these implementation in detail with coding exercise, and that may help you learn more in collections and get you more familiarized. And I'm going to upload all series of the collections videos, and I hope that will help you learning collections framework in detail. I would like to stop by now, about a little bit over the time. Thank you very much for watching this video, and we will look forward to I will look forward to upload more videos on collections, to do more coding exercise and go each one of them. Thank you again. Thank you very much for watching my video, and please continue to watch and subscribe my channel. Thank you.